Well, we discussed just now the various types of thermodynamic system, closed system, open system and isolated system, and the concept of heat and work. When heat is converted into work, it is an engine. When work is converted into heat, it is a refrigeration. Now let's move on to the next subtopic, laws of thermodynamics. LAWS, laws of thermodynamics. The first one is the zeroth law of thermodynamics. Zeroth law of thermodynamics. Since we have already discussed what is thermodynamic system, that means anything that contains some amount of matter, specific matter inside. And this is a boundary, and anything outside the boundary is surroundings. Like that, A is one thermodynamic system, B is another thermodynamic system, and C is thermodynamic system. We have considered three thermodynamic systems here. And to discuss in detail about zeroth law of thermodynamics, let me tell you what is thermal equilibrium. Thermal equilibrium means the temperature difference between two systems is nil. Thermodynamic equilibrium. Both will have the same amount of temperature. If A is in thermal equilibrium with B, that means we are considering only these two systems, A and B. Both are in thermal equilibrium with each other after the heat interaction. Now forget about A. Consider these two, B and C. Let us also assume that B is in thermodynamic equilibrium with C. That means after heat interaction, both are achieved thermal equilibrium. That means B is in thermal equilibrium with A. B is also in thermal equilibrium with C. Then obviously the system C will also be in equilibrium with A automatically. If A is in thermal equilibrium with B, B is in thermal equilibrium with C, then the relation between A and C is established, and therefore all the three systems are said to be in thermal equilibrium with each other, and that is called as zeroth law of thermodynamics. Then what is the outcome of this zeroth law of thermodynamics? The outcome of this zeroth law of thermodynamics is it gave an evaluation for temperature. Measurement of temperature. That is the outcome of zeroth law of thermodynamics. Then coming to the second one, first law of thermodynamics. Look at this sketch now, which we have discussed just now. Here, heat energy produced by the conversion of chemical energy of the fuel is converted into work. That means heat is converted into work. Similarly, work also can be converted into heat. That is first law of thermodynamics. Heat and work are mutually convertible each other. Work and heat. So, as for the first law, the cyclic integration of delta Q is equal to cyclic integration of delta W, where delta Q represents the amount of heat for a complete cycle, and delta W represents work. That means they are mutually convertible each other. Whatever the amount of heat that is generated, the whole amount of heat can be converted into work. Whatever the work that is generated can be converted into heat. That is what the first law of thermodynamics. And this gives rise to what is called as internal energy. Internal energy. Whereas zeroth law of thermodynamics gives rise to temperature. Then coming to the second law of thermodynamics. Since it is at the first year level of engineering, I am trying to give only the basics, definition and simple concept. When you come to third semester, When you enter into your real stream of engineering, these things will be discussed in detail as a subject for your information. So coming to the second law of thermodynamics, my dear students, I would like to take one beautiful example so that you understand very easily. How many of you have water tank placed on the terrace or on the top of your building? Most of us, we use water is being stored in the water tank. Let me draw the diagram. This is the water tank. And from here it comes to our usage, we use. But how does the water is initially supplied to this water tank? This is supplied from the sump, water sump. Then the water from the municipality or whatever the source of water, borewell, water is connected here. First it needs to be supplied to the water tank. But is it possible for the water to be lifted without the help of any agency here? No, not possible. Water cannot move from lower level to higher level. Therefore, you need an external agent, external aid. That is what is called as pump. You need a pump. So when you need to supply the water from the lower level to higher level, you need to switch on and the water moves to the high pressure. So water gets stored here in the water tank. But do you need a pump or a motor to supply water from the water tank for your kitchen and bathrooms? No, because of the gravity it moves from higher level to lower level. It is not required here. That is the concept of second law of thermodynamics. What does it say is, second law of thermodynamics says it is impossible to construct a machine where the heat cannot flow from lower level to higher level without the help of external agency. Good example is this refrigerator. Refrigerator works on the principle of second law of thermodynamics. Without the help of this compressor, it is not possible to supply the heat from lower temperature to the surroundings. That means all these machines, equipments are designed based on these concepts. That's why you need to understand the basics of thermodynamics. That's the reason why this chapter is meant for. So my dear students, we have discussed in brief the three laws of thermodynamics: zeroth law, first law, second law of thermodynamics. Go home and do the case studies and try to understand more about this through search engine, and come back with the answers for the assignment and be ready for the quiz. We shall have quiz in the next class. Thank you.